Students, sit up and look lively, or I swear I'll toss you out faster than a drunken punter at Wetherspoons. This is the prestigious Cavendish Laboratory, not some dingy hostel in Basildon filled with Love Island rejects nursing a cheap lager hangover. So straighten up, or I'll introduce you to the fine art of public humiliation I experienced at Harrow. Today, I have the dubious honour of reading from the lecture notes of your missing in action professor. Unfortunately, your esteemed academic can't join us, as he was last seen ziplining into the Thames in a sequined bodysuit while shouting, "Science is freedom!" I assure you, I haven't the faintest idea what inspired that particular escapade, and frankly, I'm happier not knowing. Now, don't think for a second that I'm here by choice. If I had my way, I'd be rehearsing Hamlet in a draughty church hall in Milton Keynes. But no, those bureaucratic demons at Job Search Plus couldn't care less about my history as a grand interpreter of the bard. They've dumped me here, insisting this is gainful employment, as if that excuse is making a celebrated actor stand in front of a bunch of slack-jawed undergrads. I didn't just perform Macbeth, I was Macbeth. My dagger soliloquy once moved a reviewer to tears, though I later found out it was from the chili powder in their sandwich. Anyway, sit down, shut up, and pretend you're awaiting the triumphant return of Sir Kenneth Branagh to the West End stage. Because today's thrilling topic is none other than gravitational waves. Yes, prepare yourselves to hear about space-time, velocity, and Einstein's glorious brainchild, all filtered through the dulcet tones of someone who'd rather be declaiming The Tempest at the Rotherham Drama Society. And if you so much as whisper, I'll channel my inner Prospero and rain fury down upon you. Now, where was I? Ah, yes, gravitational waves. Try not to snore, at least not loudly. Gravitational waves are essentially the cosmic equivalent of spilling coffee on the space-time continuum. Imagine you're sitting at a pond, peacefully enjoying the scenery, when suddenly someone tosses a rock in. Splash! The ripples spread, disturbing the smooth surface of the water. Now imagine that pond is actually space-time itself, and instead of a rock, two supermassive black holes collide. Boom! The ripples spread across the universe, distorting space-time in the same way, like an intergalactic ripple effect. These gravitational waves are the universe's own version of a cosmic OMG text. Hey, did you hear that? Two black holes just merged. It's a dramatic but very cool update from deep space. The whole concept is a little like the universe sending a whisper across the vastness of space, only it's a whisper that can stretch across billions of light years. It's like the universe is texting us a message in cosmic Morse code, and we're lucky enough to be able to decode it. Two massive objects just collided and danced a little waltz of destruction. If this were a pop culture reference, it would be like the ultimate spoiler alert for anyone wondering about the big cosmic events that are happening out there beyond our regular reach. However, detecting gravitational waves is no easy task. These ripples are so incredibly tiny that it's like trying to feel a hair-thin stretch in your living room. You need super-sensitive instruments to measure these minute changes. It's a bit like trying to measure the thickness of a single atom using a kitchen ruler. It's just not happening without some serious tech. That's where the LIGO, Laser Interferometer Gravitational Wave Observatory, comes into play. It's a laser-powered magnifying glass capable of detecting the smallest distortions in space-time. Imagine a ruler so precise it could measure the distance between you and the moon, and then tell you if that distance stretched by a few billionths of a meter. To put it into perspective, it's as if LIGO could detect the smallest possible bend in space-time as though it were a single wrinkle in an infinite cosmic sheet. LIGO takes this subtlety seriously, using two arms in a giant L shape, each spanning 4 kilometers, to detect the incredibly small shifts caused by gravitational waves. It's basically the equivalent of using a microscope to spot the fleeting moments of universal change that would otherwise be invisible. The sensitivity of these instruments is so extraordinary that they can detect changes in space-time that are smaller than the width of a proton, which is so tiny that imagining it is like trying to picture a grain of sand on a distant beach through a telescope from across the galaxy. So when you're talking about space-time ripples, think of LIGO as the world's most sensitive pair of ears, constantly tuned in to any whispers the universe sends our way. If the universe is sending out waves, LIGO is the cosmic eavesdropper, listening carefully to every twist and turn in the cosmic fabric. Imagine LIGO as a concert-goer at the biggest intergalactic music festival, where instead of hearing music, it listens to the bass drops of the universe. Every time two black holes merge or a neutron star crashes into another, it's like a giant thundering beat in the cosmos. And LIGO isn't just standing by passively, it's right there in the front row, tracking each beat with laser precision. So when those gravitational waves arrive, LIGO can measure every single vibration, almost as if it were the most sensitive instrument ever built for listening to the universe's greatest hits. Then, in 2015, LIGO made its groundbreaking detection of gravitational waves. And if you were a physicist at that moment, it probably felt like something straight out of Indiana Jones, but with calculators instead of whips and coffee-stained whiteboards instead of ancient maps. When the LIGO team saw the data, they thought, wait a minute, did we just detect space-time vibrations from a black hole merger 1.3 billion light-years away? It was a moment of celebration, a cosmic mic drop that forever changed how we understand the universe. The excitement of that discovery was palpable, almost as if the scientists collectively shouted, "We've cracked the code! The universe is talking!" Picture the team, sitting on the edge of their seats, eyes glued to their screens, eagerly waiting for the verdict on whether or not this was just another measurement glitch or a world-changing discovery. And when that data arrived, it wasn't just another finding, it was history-making. It was like hearing a thunderclap for the first time, not just on Earth, but from across the entire universe. The Cosmic Detective Squad had cracked the case of the century, and the prize was a completely new way to observe the deepest, most energetic events in the cosmos. Gravitational waves let us hear the universe, like a cosmic soundtrack. Imagine the universe hosting a concert, and we're only catching the bass drops, massive events like black hole collisions sending waves of energy rippling through space-time. These waves give us a way to observe phenomena like black holes, neutron stars, and the Big Bang, things traditional telescopes could never reveal. Instead of just looking at distant stars, it's like we've developed new cosmic ears, detecting signals from the depths of the cosmos. This isn't just about observing light anymore, it's about feeling the universe itself, a whole new frontier in physics, like discovering a secret level in a video game you didn't know existed. And this is just the beginning. Every gravitational wave detected is like another track added to the universe's playlist. More black holes merging, neutron stars colliding, and who knows, maybe a cosmic game of Tetris. Each event reveals more about the forces shaping the cosmos. If the universe were a DJ, it's spinning tracks that span billions of light years, each one representing a cataclysmic event, and we're all lucky to be in the audience, tuning in. Speaking of DJs, let's talk about Brian Cox, the long-haired 80s keyboardist who stumbled out of a rave and somehow ended up lecturing about the universe. Back in his D-Ream days, Cox was busy cranking out synth anthems and preaching that things can only get better. One can only assume he wandered into the University of Manchester by mistake, trading glow sticks for equations, and somehow convincing everyone that his rave-inspired musings qualified as cutting-edge science. Who better to explain the universe's heartbeat than a guy who looks like he got lost on the way to Burning Man? Gravitational waves aren't just about observing cosmic events. They're about experiencing the pulse of the universe itself, one rhythm at a time. Unlike Cox's dubious transition from club stages to lecture halls, gravitational waves offer a genuinely profound way to understand the cosmos. With each detection, we're jamming along to the ultimate cosmic rave, catching beats from the most awe-inspiring events in existence. So next time someone mentions gravitational waves, just nod and say, "The universe is throwing a party, and we're lucky to hear the bass drops." It's the greatest show ever staged, and no, Professor Brian Cox, you don't get credit for it, not the way you play synth. Things didn't get better. It's Manchester. Things can only get worse in Manchester. Manchester is a bit like Ian McKellen in Waiting for Godot, only not as turgid. Yes, I know Ian is one of the greatest living actors, but that doesn't stop him from making the audience go green with boredom in Waiting for Godot. McKellen's performance feels like it's teetering between existential brilliance and someone who just realized they left the kettle on. Sure, he brings gravitas, but there's something about seeing Gandalf reduced to squabbling over a turnip that really drives the absurdity home. The man commands the stage like he's still in Middle-earth, but instead of summoning eagles, he's fumbling with a pair of boots. You can't help but wonder if McKellen ever pauses mid-monologue and thinks, I was Magneto, and now I'm arguing about whether or not to sit down on a rock. His existential dread is palpable. Though maybe that's just the look of a man who regrets not doing another X-Men sequel instead. McKellen's performance captures the essence of Godot, two men waiting for someone who never shows up. Except in his case, you half expect him to whip out a staff and bellow, "You shall not pass!" at Vladimir just to move things along. It's classic McKellen, a mix of Shakespearean grandeur and the occasional confused glance that says, "I was knighted for this." Wait a second. And I don't mean on a cosmological scale. Ian McKellen was in The Hobbit. Benedict Cumberbatch was in The Hobbit. It's him again. He's back. Benedict bloody Cumberbatch stole the limelight from McKellen, just like he always steals the limelight from anyone on the stage with him. It's a damned cosmic conspiracy. Can't we go one bloody lecture reading without the nightmare of Cumberbatch appearing like Hamlet's ghost in every bloody scene? I'm sorry, Ian, but you should have dropped that £100 stage sandbag on his head like we discussed. You had one chance to rid us of Cumberbatch's overweening preening, and you missed. Dear students, ignore that last remark. I was just extemporizing. Great actors never, ever stab each other in the back, unless they're a Cumberbatch. And so today's reading comes to a close here at the Maxwell Theatre of the Cavendish Laboratory. Now please drag your reptilian backsides out that door and never come back.